Okay, chapter 5, number 9. That's the problem. I hope you guys know how to read, because two forces F1 and F2 act on a 5 kilogram object, taking F1 equaling 20 newtons and F2 equaling 15 newtons. Find the accelerations in A and B of figure P5.9, and that which is this guy right here. A is on the left, B is on the right. So let's get to it. So what I've done is I've written down the givens, which we've given us, and this is diagram A with a bunch of other stuff which I have done. Okay. Let's solve for A first. So this is what the diagram pretty much looked like. Okay, and pretty much it translates to this. And so the first step to finding the acceleration of when the two forces F1 and F2 act upon this object, we first solve for the resultant vector of these two vectors. And to do that, you pretty much find the resultant vector. This guy right here. And so something that you guys should realize is that the diagram was at a 90-degree angle, meaning that this is a right angle, and if you solve for the resultant vector, you get this thing, which is, half a rectangle or a triangle. So a quick way to find this is pretty much to find the magnitude of the two vectors. It's pretty much solving for the hypotenuse of this right triangle. And when you do that, excuse my bad handwriting, you get 25 newtons, and that is the force that is exerted upon the object M. Okay, so our next step is to find the acceleration, and to do that, you use the formula equals mass times acceleration. You move the variables around, and then you plug in F and M, which we got from the givens and what we just solved, this guy. Plug that in. Alright, 25 newtons over 5 kilograms. You get 5 meters per second squared. Okay, so that's the acceleration right here. Now to find the degree at which the object accelerates, we first point out that this is the x-coordinate, x positive y, this is positive x, and this is the coordinate plane where this guy pretty much just goes up that way and like that, and so this guy is F2 is pretty much 15J, and this guy is pretty much 20I. So yeah, so that is. So now to find the angle of at which the object accelerates, we pretty much solve for the tangent of this triangle, which is with this work. I should use and you should get a lot of us. Okay. You should get 36.87 degrees, or 36.9 degrees in the back of your book. How to solve for B? The diagram looks like this. Alright, that's pretty much what it looks like. And so what we're going to do is, the first step we're going to do is pretty much solve for the resultant vector of these two once again. Actually, let's solve for the magnitude of the resultant vector, and we'll do that by redrawing this to our convenience. Let's draw the x-coordinate. I don't know. Okay, that's positive y, positive x. Yeah. So let's draw it to our convenience. Solve for the resultant vector. Okay, and solving for this guy right here. Hopefully this will make things easier. Let's start off with putting down the givens. F1 is pretty much 20 newtons, and this vector right here is 15 newtons. Okay, so to make things easier, you solve the angle of this is 60 degrees, and you solve for both these, and this down here, this is 15 cosine 60, which is equal to 7.5. Okay, up here you solve for 15 sine 60, which is equal to about 12.99. Okay, now you put this right here, this and that, you put 7.5, and that's a lot of lead everywhere. Just gonna redraw this really quick. So this is what it's gonna look like, what your graph is gonna look like. The solid line down here, this horizontal solid line, is gonna be F1. This guy right here is F2, and we pretty much solve for the J component and the I component, or I mean the X and Y component, Y, X. And solve for the magnitude of the resultant vector right here. We pretty much, it's like solving for the hypotenuse of the X and the Y, and that's gonna be this. I'm just gonna keep writing really quickly. Okay, and that should give you just don't worry about what it gives you, okay? So next step is to use F equals MA. Move the variables around again, and you plug in what you got for F and M. So for F, you just plug in this guy right here. So that's the square root of 20. So that's what it's going to look like. F being this guy, M being the given. Oh shoot, it's not focusing. M being the given, which is up here, which is given to us 5 kilograms. That's the mass of the object. So solving for this guy, you get about 6.08 meters per second squared, which should be the answer on the back of your book. Yeah, that's the acceleration. Now to find the degree of the acceleration, you simply use tangent theta equals to the opposite over adjacent of this triangle, which we used, which is 12.99 over 27.5, 27.5 being 20 plus 7.5. And you solve for that, you get theta equals about 25.3 degrees. So yeah, that's how you solve for it. This is the work. I wish it would be neater. Here's the neater work. Hopefully this makes more sense. Maybe it doesn't. This probably I just realized that this could have been explained in a lot less than 10 minutes. Yeah.